All right, and tonight what we're going to be learning about is the concept of chemistry. If you've ever talked to somebody about chemistry who's taken a general chemistry class, they will remember this term, the mole. They may not know what the mole is anymore, but they do remember learning something about the mole. So what the heck is the mole? Well, a mole is just a number, and that number happens to be a really big number of 6.02 times 10 to the 23rd, but all it is a number. Okay, so we've used other words that have specific numbers associated with them in our general lingo. Mole just happens to be only a general lingo for chemists. So what are some of those specific words that we use every day? A pair of shoes, well, that represents 2 shoes. A dozen strawberries represents the number 12. A ream of paper is 500 sheets, so a ream is 500. 1 moment is actually equivalent to not 90 minutes, it's 90 seconds. 1.5 minutes, but you never knew that one. A moment in time is 1.5 minutes long. And a score of years is 20 years. So when Abe Lincoln said 4 score and 7 years ago, he was talking about 87 years ago because there's 4 scores, so that's 80 and 7 years. So notice that we use this in every single our common language. One word that we don't use, unless you're a chemist, is the mole. So what the heck is a mole? The mole is a unit that we use to count the number of particles, okay? It is the SI unit that measures the amount of a substance. This is always going to be your middle point, your base unit, okay, that you will always go towards. Unfortunately and fortunately, I guess they do abbreviate mole in science. Instead of writing MOLE, we abbreviate it by MOL. So you do get to drop that E to save a little bit of time when you are abbreviating. So instead of writing grams, we write G. Instead of writing mole, we write MOL instead of MOLE. The mole is actually equivalent to, it's also known as Avogadro's number, okay? And Avogadro's number is equal to 6.02 times 10 to the 23rd. So Avogadro's number was the guy who figured this number out. And so what you need to understand is that the mole is equal to Avogadro's number, which is equal to 6.02 times 10 to the 23rd whatevers. And that whatevers could be particle. Typically in this class, it'll be molecules or atoms or ions. So 1 mole is equal to that many particles. So if I had a mole of bananas, I had 6.02 times 10 to the 23rd bananas. If I had a mole of carbon, I had 6.02 times 10 to the 23rd carbon atoms. If I have a mole of CO2, I have 6.02 times 10 to the 23rd, and that should be molecules of CO2. Okay, so all it is a mole is equal to 6.02 times 10 to the 23rd. Now, what's really cool about this is that through all these calculations and experimentation and stuff like that, they figured out that this specific number of 6.02 times 10 to the 23rd atoms is equal to a certain amount of grams of a substance or an element. And what that is known as the molar mass. And what is the molar mass? It's the mass of 1 mole of a substance. The unit for this is grams per mole. So how many grams are in 1 mole? Typically, when I ask you to calculate the molar mass, though, your unit that you'll write down is like 12 grams or whatever it is. Okay, so how do you calculate the molar mass? This is that mass that we've always talked about on the periodic table. Very few people ever ask, well, what does that mass mean? Then what is the unit of hydrogen being 1? What is the unit that helium is 2 or 4? What does that mean? Well, it's actually equal to 4 grams for every 1 mole. So if I had 6.02 times 10 to the 23rd little atoms of helium, it would be equivalent to 4 grams. So how do we calculate it? First, use the periodic table, which we will always give you on every test. You will never have to memorize. You find the mass of each element in the compound. In this class, we're going to round that number to the nearest 10th. Okay? If there are any subscripts next to that element, you multiply the mass for that element by the subscript number, and then you add up all the masses together, and that's the molar mass of that individual compound. So let's try to do some example problems. So if I just wanted the molar mass of carbon, all I have to do is look at my periodic table, and I notice that carbon's periodic table on mine is 12.011 gram. Well, there's no grams, but That's what now the unit is. And I just want you to round it to the nearest tenth. So we're going to be rounding it to there. So that would be 12.0 grams for every 1 mole. If I wanted water, there are 2 mole for every 1 mole of H2O. There are 2 moles of H and there's 1 mole of hydrogen. Or of oxygen. So what you're going to do is you're going to take 2 moles and you're going to take of hydrogen. Each hydrogen has a mass of 1.0. And then I'm going to add it to 1 mole of oxygen, each with a mass of 16.0. Where am I getting this 1 and this 16? I'm looking at my periodic table and rounding to the nearest tenth. So added up, that is equal to 18.0 grams per mole. So the molar mass for oxygen or for water is 18 grams. For calcium carbonate, so CaCO3, you're going to have 1 calcium, each with a mass of 40.1, plus 1 carbon, each with a mass of 12.0, plus 3 oxygens, each with a mass of 16.0. So when I add that up in my calculator, which I'm doing right now, you are going to get 100.1 grams. Okay, so that's the molar mass of calcium carbonate. All right, what's really cool is that we're going to be using this conversion, this molar mass conversion. So typically I'll ask you what the molar mass is, but you're not actually going to use that directly. That's only part of the problem. What you're going to do is that you know that the conversion is for every 1 mole, there's X amount of grams of the molar mass. And this changes just depending on what element, what compound, what molecule you are talking about. So the conversion that you're going to use is 1 mole is equal to the molar mass in grams. We're going to be doing the same exact conversion method called dimensional analysis as we did first semester to do these. So if I am asking how many moles are there, so this is my question, how many moles are there in 28 grams of magnesium chloride? What you're going to do is you're going to start with your given, which is whatever the number is. So I'm going to start with 28.0 grams of MgCl2. Just to let you know, as far as points go, you're going to get a point for the number, a point for the unit, and a point for the magnesium chloride written. Okay, we're going to set up our lovely chart. Then we're going to put grams on the bottom so that my units will cancel, and I can go directly from grams to moles. I'm going to write MgCl2 and MgCl2. And I know that it's 1 mole. What I don't know is what is the molar mass of MgCl2. So now I'm going to do a little side problem over here, which I do want you to show the work for. 24.3 times 1 plus 2 times 35.5. Okay, and so we get 71 from the 35.5 plus 24.3. So we get our molar mass is 95.3 grams. So I'm going to put in 95.3 grams for this guy. And how I'm going to solve it is I'm going to take 28 times 1 divided by 95.3, press enter, and I get 0.2938. And that would be moles of MgCl2. Now what I need to do is round to my nearest sig figs. You're going to base it off of the number that's given in the problem. So this has 3, so I'm rounding to 3. It's 1, 2, 3. That number is going to round up because of that 8. So I end up with 0.294 moles of MgCl2. Okay, now I want to calculate the mass of 1.3 moles of nickel 2 phosphate. Okay, so this is my number I'm going to start with, 1.3 moles of Ni3PO4 2. Okay, moles has to go on the bottom. Remember to write whatever substance you're talking about, so nickel 3PO4 2. And I can go directly to grams, so I'm going to put nickel 3PO4. Now I need to figure out the molar mass of nickel 2 phosphate. So we've got nickel is 58.7. I've got 3 of them. P is 31, and I've got 2 of them. And oxygen is 16, and I have 8 of them. So when we add this up, we get 366.1 grams. So it's 366.1 grams over 1 mole. So now we're going to multiply 1.3 times 366.1 divided by 1, and we get 475.93 grams of Ni3PO42. And so rounded to the 2 sig figs, this would round to 8, so it would be 480 grams. All right, now what also is cool is that there are tons of different conversions that we can do to go to different amounts that we can actually measure in lab. We can't measure moles. Like there's no balance with a mole. There's no glassware with a mole on it. So what we have to do is we have to do things and convert them into things that we can measure. So we can easily measure grams, and what we can easily measure is liters. And the thing is that they figured out, Avogadro did, that for every 1 mole, there's 22.4 liters of a gas. So it takes up 22.4 liters of gas. Now, this conversion only works for gases, and they have to be at this special thing called STP. What is STP? It's a condition that you put it on. It means standard temperature and pressure. That's where the S, T, and P come from. What is standard temperature? Standard temperature is 0 degrees Celsius for the temperature, and the standard pressure is either 1 atmosphere, 760 millimeters of mercury, or 101.3 kPa. Now, these are all equivalent to each other. It just kind of depends on what science you're studying. Atmospheres tends to be if you're a chemist. Millimeters of mercury tends to be if you're a meteorologist or studying weather, and kilopascals tends to be if you're a physicist. So depending on what kind of science you're studying, you use all these different units, but these are all equivalent. And 1 atmosphere is at sea level, about the pressure that you feel from the atmosphere. So that's why they give it 1 atmosphere. 0 degrees Celsius is where ice freezes. So whenever we say it's at STP, scientists know that the gas is at 0 degrees and that it's at 1 atmosphere of pressure. So this is the conversion that you can use if you are trying to go between moles and liters and moles. Is 1 mole is equal to 22.4 liters. You will have to have that one memorized. All right, so calculate the number of liters. So I'm asking for liters of 5.5 moles of oxygen at STP. So it's important that I wrote STP. For this unit, if we're not writing STP, pretty much you can assume that it is, and that was probably just a typo I'm forgetting. All right, so we're going to start with our number, which is 5.5 moles of oxygen. Remember, oxygen is a Hunkelbrief, so we're going to have that diatomic of O2. Moles can go on the bottom, and I know a conversion between moles and liters directly, so I can put the liters on top. Once again, write down whatever substance you're talking about. Now, I do know the conversion is 1 mole for every 22.4 liters, so I'm going to put that in there. I'm going to multiply 5.5 times 22.4, and I get 123.2 liters of oxygen. Looking at my sig figs for 5.5, that's 2 sig figs. So now I'm going to round my answer to sig figs, 1, 2. So this would end up to be 120 liters of oxygen. And the last conversion that you're going to need to know is kind of going back to the original slide, which is the main conversion of 1 mole. There are 6.02 times 10 to the 23rd particles. Okay, and particles could be standing for formula units for ionic compounds, molecules for covalent, or atoms for individual little elements. All right, so this is the conversion that we will be using for this one. So how many moles are there if there are 4.5 times 10 to the 22nd molecules of sodium sulfate? So what we're going to do is 4.5 times 10 to the 22nd molecules of Na2SO4, which is sodium sulfate. And we are going to put molecules on the bottom. Molecules can be abbreviated MC. And then it's Na2SO4. And then 1 mole can go on top. And the conversion is 6.02 times 10 to the 23rd. And you will have to have that memorized. So when you're putting this into your calculator, remember that E button that we used before. You're going to type in 4.5 second E 22 times 1 divided by 6.02 second E 23. So when you type this into your calculator, which I'd like you to try to do, you get 0.07475 moles of Na2SO4, which rounded, that would be 1 sig figs. So it's 0.075 moles of Na2SO4. Okay. All right. So those are the individual conversions. But remember, 1 mole is equal to 6.02 times 10 to the 23rd. 1 mole is equal to this molar mass, and 1 mole is equal to this amount of volume. You will have to have all of those memorized. Therefore, all of them are actually equivalent. So if I said I have 6.02 times 10 to the 23rd atoms of a substance, that means if it's a gas at STP, I also have 22.4 liters of that. Okay, so they're all equivalent. What you're going to be needing to do for this is you're going to be using this type of mole map. Now you will have this mole map memorized, but it's just kind of nice to follow along. So how many atoms, so I'm asking for atoms, are there in 45.5 grams of lithium sulfide? Okay, so I know I'm starting at 45.6 grams of lithium sulfide, and I need to go to atoms. So I only know from the previous ones the conversion between grams and moles. So what you're going to have to do is use this mole map. We're starting at grams, which is right here, and I need to get to atoms, which is over here. So I am going to need to do one conversion to get to moles, and then another conversion to get to atoms. Okay, so starting this off, first I'm going to deal with my grams to moles. So I've got 45.6 grams of lithium sulfide, and I need to get to moles because that's my first step according to this mole map. You always have to go through the mole. So we've got grams of lithium sulfide, and I know I can go to 1 mole of lithium sulfide. Okay, so to do this, I know that grams is the only one that actually changes depending on what the substance is, unlike liters and molecules. So it's going to be 6.9 times 2 plus 32.1 times 1. So we get 6.9 times 2 plus 32.1. It is 45.9 grams. Okay, but I'm not done because I'm only at moles and I need to get to molecules, atoms, formula units. So in this case, I'm trying to get to atoms. It actually shouldn't be atoms. It should be molecules because this is actually it should be formula units because this is a ionic compound. So we're going to go moles on the bottom because I'm moles on the top for this one. So it's Li2S, and we're going to go to formula units of Li2S. Okay, and so what is the conversion between moles and atoms? It is 6.02 times 10 to the 23rd. So I'm going to do 6.02 times 10 to the 23rd formula units. So now putting this into my calculator, I'm going to do 45.6. This should be 45.9. No, this is 6. I'm sorry. That's 45.9. I'm getting confused. So we're going to do 45.6 times 1 divided by 45.9 times 6.02 E23 divided by 1, and we get 5.98. Okay, that's with sig figs, times 10 to the 23rd formula units of Li2S. All right, calculate the number of grams. So I'm going to go end up here from 34 liters of CO2. So my route has to be going this way. So I'm going to go up and over. So the first one I'm going to use is that 22.4. So 34 liters of CO2. Notice that I'm writing my units every time and I'm writing the substance every single time. Liters will go on the bottom because liters is on the upper left on this one, and I'm going to go to moles, which is on the top. So it's 1 mole of CO2, and the conversion is 22.4 liters of CO2. Now I'm ready, I'm right here at moles. Now I need to go to grams. So moles will go on the bottom of CO2. Grams will go on top of CO2. And I know that it's 1 mole, but now I need to use the formula mass or the molar mass. So it's 1 times the mass of carbon, which is 12.0, plus 2 times the mass of oxygen, which is 16.0. So we get a total mass of 44.0 grams. So put that in, 44.0. And so we're going to take 34 times 1 divided by 22.4 times 44 divided by 1, and we get 66.786 grams of CO2. Now rounded to the 2 sig figs, this should be 1, 2, so it's 67 grams of CO2. All right, we'll be practicing more of these in class. Hopefully you kind of have a basic understanding. The mole map is probably the most important thing to understand out of all of these, and we'll talk about it more tomorrow.